This is page 40 in your notebook. I'm going to start by talking a little bit about gas itself and the things we're measuring, and then we will get into the gas laws. So the first gas law, Boyle's law, talks about pressure and volume. Pressure is actually a measure of the force of the impact of the molecules. So how hard the different gas particles hit the surface of the container is actually the measure of the pressure of that gas. Then volume, on the other hand, is the amount of space that it's filling up. As you can see that if I hit with more pressure, then the volume will increase. So then the third thing we're going to be looking at is going to be temperature. So temperature actually has to do with the speed of the atom. So, or molecule, or whatever the gas particle is. The faster it is, the higher the temperature. Now, it isn't a direct relationship. There are some averages and square roots involved here. But what I want you to think about is if we have a higher temperature, that means that the particles are moving faster. If we have a lower temperature, that means the particles are moving slower. But the most important thing you must remember about temperature is that when you get it in degrees Celsius, you need to convert it to Kelvin, which is absolute temperature. And you do this by taking the degrees Celsius and adding 273.15. Okay? So any time you see degrees Celsius, you need to convert it to Kelvin whenever we are talking about gases. Super duper duper important. Okay, now the first three gas laws that we're going to be taking a look at are going to assume that the number of moles is obviously the number of particles, and they're assuming that there are no leaks. So basically this is constant. Then in the next video I'll talk about something called the ideal gas law. The ideal gas law allows us to account for change in the number of moles. So those are the different variables we're going to be looking at. We have pressure, volume, temperature, and moles. Moles, of course, is going to be constant for right now. And now we're going to go in and we're going to actually fill in these boxes, and I'm going to start here with Boyle's law. Boyle's law is P1 V1, this is multiplication, equals P2 V2, which is also multiplication. Now, the 1 indicates before any change, and then the 2 indicates after. So we are comparing two different sets of conditions for the same system. The things that are constant here, so in the bottom of your box you see the word constant, are going to be any variables that are not in this equation. So for Boyle's law, the constants will be temperature and the number of moles, which from here on out I'm going to abbreviate using N. N is the variable that we use for number of moles in all chemistry equations from here on out. So that means, well, these things are constant. The things that can change are pressure and volume. Pressure can be in a variety of units because we measure pressure in different units depending on the situation. Volume, we are always going to operate with volume in terms of liters. So if you see anything other than liters, you need to be able to convert it. Okay? So once again, Boyle's law, we have conditions before, conditions after. The things that need to be the same or not change in order for this law to work are temperature and the number of moles. So we can't have gas leaks or things like that. And then pressure can be in a variety of units, but it does need to be the same between the first pressure and the second pressure. And then volume needs to be in liters. Next up will be Charles' law. So Charles' law is the relationship between volume and temperature. Here you can see that while pressure and volume are multiplied together, meaning that they are inversely related, volume and temperature are divided, which means they are directly related. Means that if I take pressure and in my other conditions I increase the pressure, in order for this to continue to be true, we have to then decrease the volume. So increased pressure will result in decreased volume. Whereas here, for this relationship to remain true, if I increase the volume, I must also increase the temperature for that to be true. We will explore those relationships so they make a little bit more sense in the future. Here, our constants will be, as you have probably guessed, pressure, and once again, moles. What will be changing will be the volume, which will be in liters, just like I said before, and the temperature, which must be in Kelvin. Okay, then the last of our three laws that we will combine is called the Guy-Lussac's law. Oftentimes you'll see this without even a name mentioned because the history behind this particular research is a little bit more muddled than the other two pieces of research. And this is going to be pressure divided by temperature. So now we've taken each of our three individual variables and we've related them. This is again going to be directly related. So if I increase pressure, the system must also increase temperature, assuming that volume and moles are constant. Pressure can be in many units. And temperature, quiz yourself, what is temperature going to be in? It's going to be in Kelvin. We get Kelvin by taking degrees Celsius plus 273.15. This right here is a number worth memorizing. Okay. Now, let's say that you run into a situation, like probably one on the back of your sheet, and you find out that pressure, temperature, and volume have all changed, but moles are constant. Then you're going to use what's called the combined gas law. On your notes, that's going to go right here. So the combined gas law is the same idea. We have a start, and we have a final. In fact, if you're looking at resources on the internet, you will often see that this 1 is written as an initial, and this 2 is written as an F for final. Okay? But they mean the exact same thing. If you see all I's and F's, it's the same thing as what we've done here. So most of these problems will be plug and chug. You read, you identify information, you identify unknowns, and you select the correct equation. So I'll do some other related examples in another video, but I'm going to pause here and let you get everything written down, and then the next video we'll talk about the ideal gas law and the constant R.